Okay, so now we are finally already in our module 7. This is just an additional problems involving curvilinear motion. Okay, so in this module, I will present more problems from curvilinear motions. Okay, so mo nga punto nga concept, we just remember na curvilinear motion nga ang tangential acceleration is constant, then we can use the constant acceleration equation from the kinematic equations. If not, then we can use also the kinematic equations for non-constant acceleration katong tulong kuan ay derivative. The a is equals to derivative of the velocity with respect to time. The velocity is just equal to the derivative of the position with respect to time. And then kato pong na relationship nga velocity times derivative of the velocity katong v dv equals a ds. So here we can solve for these problems using those equations. Okay, for our sample problem number 1, the boat Dokuno is traveling along a circular path. This is already module 7, sample problem number 1. So ang boat is moving in with a circular path. Speed is, so ang always good nga speed nga itong ginistoryahan dire is katong velocity nga tangent sa path sa curve. So ato ang given velocity, we have the equation velocity is equal to 0.0625 t squared. This is in meters per second squared. So this is in SI units or metric system. So we are asked about the magnitude of its acceleration when the time is equal to 10 seconds. So the magnitude of the acceleration at time is equal to 10 seconds. So saan man nato pagkuha ani sa magnitude of the acceleration? Okay. So again, maro gito nga formula no, ang magnitude of acceleration is just equal to tangential acceleration squared plus the normal acceleration squared. So unsa na to pagkuha ni tangential acceleration squared? If you remember, velocity and tangential acceleration, best friends ni sila, na sila relationship. So we know that ang tangential acceleration is just equal to derivative of the velocity with respect to time. So just the derivative of this one. So pila may derivative ana? 0.0625 t squared. So it's just equal to 2 times 0.0625, that is 0.125 t. So this is our tangential acceleration at 10 seconds. So our tangential acceleration at 10 seconds is just equal to 1.25 meters per second squared. So naana tayo tangential acceleration. Ato na pong kaon si normal acceleration. So normal acceleration, again, a sub n is just equal to the square of the velocity over rho. So natay given nga rho, which is 40 meters. So ato na isulat diri. The radius of curvature is equal to 40 meters. So pila man atong velocity? Atong velocity is 0.0625 t squared. So at 10 seconds, we substitute 10 seconds sa t squared. So the velocity becomes at 10 seconds 0.0625 times 10 squared. You can 6.25 meters per seconds. So this is meters per seconds today. 6.25 meters per seconds. Ato na i-substitute diri. 6.25 meters per second squared kay square man. And then the radius of the curvature equals to 40 meters. So ato ang normal acceleration is just equal to 6.25 squared over 40, 0.977 meters per second squared. We already have the normal and the tangential acceleration. Then we can solve for the magnitude of the acceleration. So magnitude of the acceleration is just equal to square of the tangential acceleration plus square of the normal acceleration. And then extract them to square root. So our final answer is just equal to 1.25 squared plus 0.977 squared. Our magnitude for acceleration is just equal to 1.587 meters per second squared. So this is for our sample problem number 1.